Welcome to this, the November edition of the IoT Security Foundation monthly webinar series. We didn't have an October edition due to last week's annual conference, and we don't do this webinar in December. So this, I'm sorry to say, with a tear in my eye, is the final webinar of 2025. As we approach the final weeks of 2025, we're gearing up for the TechWorks Awards and gala dinner on the 3rd of December in London at the very posh Royal Lancaster Hotel in London. It's right beside Hyde Park, for those unfamiliar. TechWorks is the parent organisation of the IoT Security Foundation. We also have communities for semiconductors, AI, and automotive, and they all come together for one big black tie event, and we dish out some well-deserved awards as well. Nominations for the TechWorks Awards are closed, I'm afraid, but the big category for us here at the IoT Security Foundation is the Cybersecurity Leadership category. Last year, it was won by our friends at Skills Da in Chennai. Keep an eye out for the announcement of the nominees for 2025 coming very soon. So let's get right into it. Today, I'm joined by two gentlemen from ZF, and they are presenting Cybersecurity Engineering, an automotive perspective on frameworks, tools, and processes. A bit later, we'll have Sergio Scabar. But first of all, joining us from Birmingham, it's Alan Jacobs-Cook. Alan, the floor is yours.
Oh, thank you. Okay, let me share my screen. Are we seeing that coming through?
Good to go, Alan.
Okay. Okay, so quick introduction. Who's ZF? It's probably one of the largest business companies that nobody's heard of. ZF is actually one of the top 5 largest tier 1 suppliers in the automotive market by turnover. And typically ZF products include transmissions, steering and braking systems, radars, cameras, electric drives, airbags, and seatbelt retractors. So pretty much every electromechanical system that you can put on the vehicle. ZF Engineering Solutions, where myself and Sergio work, we're a standalone consultancy within ZF, providing services to customers within and external to ZF. Within ZES, or ZF Engineering Solutions, I manage the pen testing and evaluation group. And that's within the Cybersecurity Center of Competence. Okay, so what I'm going to talk about today in automotive cybersecurity, I'm going to start off with an intro into what were the key sort of drivers to cybersecurity in automotive. Then I'll go into a little bit on the frameworks. I'll then touch on 2 key elements of it, the TARA, threat analysis and risk assessment, and penetration testing. And then I'll finish off with some thoughts on maybe where we can go from here. Okay, so in terms of the context to start off with, it's very much an embedded system context. You have a range of systems in vehicles these days. They're all pretty much electronically controlled, ranging from engine control systems to chassis control, airbag systems, advanced driver assistance systems, telematics, infotainment, and then more recently, you've got e-drives as electric vehicles become ever more prevalent on roads. Typical system characteristics that you're going to encounter, it's very much a real-time operation. It's not like you can't have any blue screening. It's got to be up and running, and it's got to do that in a short period of time. It has to be deterministic. You're also constrained in resources in terms of memory, power, and processing, and cost is everything in automotive. So you pare it right down to the minimal microcontroller that you can actually deploy. Safety critical, basically ZF is a safety critical company. Most of the systems that we develop and sell are related to braking, steering, e-drives, anything like that is safety critical. And obviously security has to be integrated in the product. We also have a number of interactions and interfaces where you've got vehicle to infrastructure, cloud platforms, you've got diagnostics, maintenance, over-the-air updates, and driver experience monitoring as well. A lot of information. All of this gives a big attack surface potentially to an attacker who may be interested either in, it may be for reasons to for tuning, for example. There's been a big push in the past, or it may be for other nefarious reasons. Okay, so next one. In terms of the driving forces and key milestones, it really, I think the 2015 Jeep Cherokee hack was one of the initial kicks that the automotive market sort of really needed. There was obviously a lot of tuning related hacking going on before that, although it wasn't thought of as hacking at that time. It was more just about tuning and developing and improving performance of vehicles like the engine and whatnot. And hacking wasn't really a thing until later, more recently, within the last 10 years or so. You then had the NHTSA guidelines come in, and I think really what has pushed it is the regulation R155, because without cybersecurity management system in place, you're not able to homologate the vehicle, and that's really when things started to push in. And that kicked in from 2022 onwards. And then in addition to that was the 21434 standard. Generally, the vehicle manufacturers, the OEMs, follow the R155 because they need to homologate the vehicle. And tier ones like ZF, we follow the ISO 21434 standard, and we follow those practices. So if I now just elaborate a little bit on the key elements of ISO 21434. This is basically the scope of it. Applies to everything electronic in the vehicle across the whole vehicle life cycle. So that's basically from cradle to grave. And cybersecurity has to be integrated from the concept into production, operation, maintenance, and end of life. So basically, cybersecurity has to be integrated throughout that life cycle. And increasingly, we're seeing the CSMS, Cybersecurity Management System, SAE 21434 compliant, is something which the OEMs are increasingly requiring of their suppliers. And that's something that ZF has already, is that certification. And then you have distributed cybersecurity activities and how you flow up and flow down the cybersecurity requirements through the supply chain. And it starts with the OEM, flows down through tier 1 to tier 2, and sometimes even to tier 3 suppliers. And then you have the project-dependent elements of it, where it's tailored specific to the needs of each project, and with the cybersecurity plan and the work products. The other element, which is a strain which runs completely from cradle to grave again, is continual cybersecurity activities, where you've got the Security Operations Center, where you're monitoring, identifying, and evaluating events, whether that may lead to weaknesses or vulnerabilities, and somehow managing those as well. And then one of the other elements which I'll now come into following this is the TARA. And for me, this is the foundation of your cybersecurity analysis, and the sort of the bedrock of your cybersecurity case is the threat analysis and risk assessment. So if I now just go into, sorry, I'll come to the TARA in a second, but if I just map on the cybersecurity activities onto the V cycle, the automotive V cycle. We start on so at the top, we've got continual cybersecurity activities here. So this is what we talked about, the VSOC, lifetime support and continually monitoring throughout the life cycle of the product. Then when you, through the life cycle from plan, develop through in-field to end of life, You start off with the item definition, then you develop the TARA. From this, the TARA results in cybersecurity goals and claims, which as they make up the cybersecurity concept. You then have the vulnerability analysis, which you can feed in at the design stage. So you look at, for example, are you using open source software? And are there any weaknesses or vulnerabilities already existing in that you need to take account of? Then you implement your cybersecurity controls, and this may include hardware security modules. It may include secure communications, etc. And then on the right-hand side of the V, you start with testing, and you start off with vulnerability scanning for known vulnerabilities. You might use tools like Black Duck, but a lot of these tools target the existing IT vulnerabilities. There aren't the embedded system vulnerabilities are not as well covered by the existing tools, vulnerability scanning tools, but some of those are. So at least you've got partial coverage. Then you get into functional testing, and then you from there into fuzz testing and pen testing, which I'll elaborate on a little bit more. And then finally acceptance, where you have the cybersecurity case. So basically on the left-hand side, you have your documents for this is the design side of it, and then the testing analysis, and that matches across from one to the other at each level. So getting into the TARA. The TARA starts off with asset identification, and this includes looking at the confidentiality, integrity, and availability of the particular asset. You then split into two, where you look at the impact rating on the one side, and then you look at the potential threats using the stride factors. You then do an attack path analysis. You get an attack tree. And from that, you formulate attack feasibility ratings as to how likely the possible attacks are. You then combine that with the impact rating on SFOP aspects, and then you come up with a risk value determination of the impact times the probability. You then decide, are we going to avoid the risk? Are we going to reduce that risk? Is it something you can only share with the OEM, or do you accept that risk because either there's nothing you can do about it, or it's a fairly low feasibility, maybe with a low impact? And then your risk treatment forms from that, you elaborate your goals and your claims. So your goals are, this is what we will aim to do to protect the cybersecurity aspects of the system. And the claims maybe are where you say we're not going to accept, or we're not going to cover certain aspects of it. And that's what forms the cybersecurity concept. So ZF is quite, I guess, unusual in the way that it approaches the types of cybersecurity testing. Often you'll see penetration testing actually combines fuzz testing and penetration testing together. In case of ZF, we split these discretely into two different elements. So you start off with your functional testing, which is basically, is it functionally correct? You then go into your fuzz testing, which is basically you're sending altered or mutated data to the system, or perhaps over the communications bus, and looking for different responses, unexpected responses. And that gives you a clue as to there may be some weakness or potential vulnerability there. You can also do vulnerability scanning, and that looks at existing vulnerabilities that may be there, but maybe haven't been caught already in the functional testing. And then penetration testing is where we will often look at use the fuzz testing as a source of reconnaissance, and that gives us a clue to where we look at. And then pen testing is much more manual and goes into the depth of how can we exploit this potential anomalous behavior in the system, and can we make it do something and use that in order to compromise the cybersecurity controls. And then the type 4 testing, this is where you're into your security operations center, and you're using this mechanism as a way of trying to identify zero-day attacks, new attacks that have been thought of already, and trying to stay one step ahead of the attackers. So in terms of inputs to pen testing now, this just gives you some insight into the kind of the expanse of the interfaces that we've got to cope with. Some of these are historical, they've been around for years. J1939, for example, in the protocols is heavily used by the commercial vehicles industry. You also have VM-specific, OEM-specific runtime communications. UDS over CAN is very important. There's a couple of things in there. If you got access to the JTAG, or you can re-enable XCP, those are design engineering protocols. And basically, if you can get through those, that's it, it's game over. You've got through the front door and you've got access to everything, including firmware. You can reprogram it. You can do whatever you like. So it's very important. Those are big attack surfaces. UDS is one of the biggest. Code download, where you say you're putting you're reprogramming the firmware during a vehicle service, for example. That's another very important area where we have to look at, because those are quite critical. If you get those wrong, then you could leave yourself open to attack. And then in terms of the controls, there's various controls that get implemented. In the past, secure communications, onboard communications was just not a thing. And you could easily get, basically it was open. So if there isn't secure communications, then we just don't look at that pen testing, because you can get into it anyway, so there's no point testing it. As I said, the UDS has security key management. That's very important, because you have to assess what levels are authorized. So a mechanic in a garage would only have a certain authorization level to pre-program. He wouldn't be able to modify or update. Others might only have a level where you can read the codes, maybe fault codes. So UDS is very much like OBD, but much more sophisticated and standardized than OBD is. And ultimately, UDS will be replacing OBD in the near future. Then you've got the hardware security module, various encryption mechanisms. Secure boot is very important. And also, you really want to stop anybody from rolling back the code to a previous version of the firmware, which may have some vulnerabilities or weaknesses built in, which could potentially be exploited. And then you can use that to take over the system and then control it, even with a newer version of the code. And obviously, these need to be implemented along with lifecycle management protections as well, such as being able to move from production mode to development mode. And then further inputs that we would seek, as well as understanding the actual product itself and what interfaces and protocols, etc., that it has, we would look to get a view on the security goals. Some of those might be flowed down from the OEM. Primarily, most of them will come from the actual product itself. So there would be an analysis. The TARA would provide the security goals. We would also seek to get the TARA, or at least the attack paths and controls from there, because then we do a mapping of these are the penetration testing activities we'll do to attack the particular controls, and to provide them the coverage that they're seeking in the pen test. In terms of an attacker model, at this point in time, it's mostly around looking at tuners and people who are basically looking to develop and sell tuning tools. these sort of state nation attacks aren't something that we're considering at this level. It's mostly tuners is the concern, because that might make ZF open to potential emissions regulations or any sort of vehicle regulations that cover, and we might be non-compliant to that if an attacker somehow manages to compromise the system and manages to tune something like either a transmission or engine or e-drive or whatever. We assume that they've got access to plain text or encrypted application binary, and we assume they've got access to UDS scene key mapping for the bootloader as well, and to the debug port. Okay, I need to crack on and look at my time at the moment. So just in terms of some of the pen testing data that we've had, we can see in general from 22 to 24, there's been a reduction in the number of findings that we found. The main one is in config, and that's dropped quite considerably. And then you can see UDS is another one which is ticked up again more laterally as that's become a little bit more complicated. Let me quickly move on. So then once we've got the feedback from the pen testing, this feeds into the TARA, and then you then have a residual risk. Basically, your attack feasibility might have changed as a result of that analysis. And you have to go through this again and then identify what's your residual risk that you've actually got, what you're willing to accept, what do you need to do. You may need to do further development and fix the findings and the control. We may have found some weaknesses in the system, and you need to then fix those again. So having done that, if I now just touch on the AI potential role in cybersecurity testing, then clearly there's opportunity for automation and smart mutation, adaptive generation and anomaly detection, and for fuzzing sort of self-learning and reinforcement learning and response patterns to the UDS services. In terms of penetration testing, we're already to an extent using AI to help develop the Python code that we use for testing. Where I'd really like it to go is where we can identify new undefined corner case weaknesses that we may not have ordinarily come across before. So I think in the reconnaissance, I think that can be really, really beneficial. And then in additional applications, looking at real-time monitoring. If you've got vulnerability reports, and these are big reports, then natural language processing helps you to process that and extract that information. Okay, I'll just touch on a little bit on the Cybersecurity Operations Center and red teaming. And basically, this is the need to cover the whole life cycle from cradle to grave, but particularly when it goes into service, you need to look at monitoring for events, incident management, red teaming activities, trying to stay ahead of the game. Okay, and then I think this is just last but one slide. So in terms of, I'll just open them all up actually, to be honest. I think we're looking at, in order to be agile, you need to integrate security from the off and basically be prepared in advance to be able to identify and respond quickly to emerging vulnerabilities. Continuous threat monitoring is obviously essential. Post-quantum cryptography is something which ZF is already looking at preparing for in terms of having future cryptographic solutions that we can embed. It doesn't need to be quantum devices to do that. It's just basically cryptography, which is sufficiently secure against post-quantum techniques. And then preparing for upcoming standards. The Chinese cybersecurity standard in particular is, I think there's a latest one, GBT 46194 2025. That's just come out in October 2025. And the Chinese have very much a focus on data localization. So you need to maintain and keep that data in China. Okay, and then just to finish off, apologies, I've gone 5 minutes over. The automotive, I think where I see the automotive market has got to, or the automotive industry has got to today, is we've done well adapting existing IT frameworks and cybersecurity capabilities. We've generally built those frameworks on top of the existing ones, so we have engineering development frameworks. I think there's an opportunity there for further streamlining and improving the efficiency and integrating those better. I think if you're a new industry player, then it's easier to adopt and manage things anew because you don't have legacy frameworks that you have to work with. But I do think there's a lot of good stuff that's come from the automotive industry so far, and I'm sure that we could migrate some of that, share some of that with other industries. I think that would be a healthy thing to do for us to collaborate cross-industry. I think the IoTSF security assurance framework is a really good guide on what to do. And I think the automotive processes and tools and templates, they really target the how do we do it. And I think that's sometimes the challenge is how do you do it and how efficiently can you do it? And I think I'd just like to finish on the last point here, which is a real key point. If you can commonize your product platforms, and what I mean by that is the cybersecurity controls that go into those platforms, you can reuse a lot of that. You can spin off variants, and you don't need to do as much cybersecurity engineering into those work products as you would do if you're doing everything from scratch. So that's me. Thanks for listening. And I'll hand back to Chris.
Thank you very
And I'll
much,
stop
Alan
sharing at this point.
Jacobs Cook. If you're watching this video on YouTube and you're liking what you're seeing and hearing, please like this video and subscribe to our channel. It helps us more than you know. Alan, whilst I've still got you, I've actually seen you more recently than I have my own family members because you were at our annual conference last week in London. This past Thursday, in fact. So I just wanted to ask you, what were your thoughts on the conference, and what were your key takeaways?
I've enjoyed it very much. I think it was a really good networking event. The location was perfect at the IET overlooking the Thames. I managed to have quite a number of interesting conversations and potential collaborative opportunities from that. And one key conversation we had with a potential customer who could possibly make use of some of the services that we offer. In terms of the presentations, there was a lot of really interesting presentations in there. And I think the keynote speaker at the end, Dex, was just, I mean, if there'd been any open for questions, I would have asked him if he wanted to run for Prime Minister. That was just a fantastic presentation that he gave into the potential great outcome of technology and the potential disastrous outcome that that humans have in front of us. And that was we would have liked to have stayed longer for the drinks and reception. I think that's something to plan for next year. Maybe we'll spend 2 nights rather than 1.
Absolutely,
because I think there's maybe some good discussions go on after the conference as well. But we had to shoot away early, unfortunately. But no, a great event, and we look forward to next year's event as well when that comes.
Yeah, and not only was the substance of Dex's presentation just absolutely fantastic, he's such an eloquent speaker as well, wasn't he?
Oh gosh, yeah.
He would actually make a very good Prime Minister. That's not a stretch. Okay. Just to mention some online meetings that are coming up soon from the IoTSF. The first one is tomorrow. It's the November meeting of the IoTSF Smart Built Environment Working Group. If you're watching this recording, that meeting will probably have passed by now, so apologies if you're watching this recorded. On Monday, the 10th of November, we'll have the latest Regulatory Watch Working Group meeting. Wednesday, the 12th of November, it's the monthly get-together of the IoTSF Assurance Framework Working Group. Friday, the 21st of November, it's the monthly meeting of the brand new Energy Special Interest Group. And lastly, for the moment, on Tuesday, the 9th of December, it's the last meeting of 2025 for the Device Identity Forum Working Group, Device Identity Forum Working Group. Getting confused with Device Authority, who are one of our valued members. I'd like to, if you'd like to attend any of the online meetings that I've just mentioned, go to the IoTSF members platform and you'll find details and Zoom links there. I've also, if you're watching this live, put a link in Zoom chat, which will take you to IoTSF /events as well.